Okay, so today we're going to talk about section 7.4. We're still going to talk about our trigonometric ratios, but instead of finding the measure of a side of a right triangle, now we're going to find the measure of a missing angle. So just as a warm-up here, if I wanted to solve x plus 4 equals 10, in order to solve that, I would subtract 4 from both sides. Why? Because adding and subtracting are what's called inverse functions. They cancel each other out. So same thing when I look at x squared equals 9. How would I solve for x there? I would take the square root of both sides. Why? Because squaring something and taking the square root are inverse functions. They're the opposite of each other. So when we're talking about angles, to find missing angles, you're going to use the inverse of your trig functions. So this is how you would say what I just circled in blue. That's the sine inverse of x. This is the cosine inverse of x, or this is the tan inverse of x. So if you look directly above your sine, cosine, and tangent keys on whatever type of calculator that you have, right above them, you're going to see sine inverse, cosine inverse, and tan inverse. Okay, if you are using the iPhone, you are not going to see the inverse function pop up until you hit the second key. Once you hit the second key, these three trigonometric ratios will all change from the sine, cosine, and tangent to sine inverse, cosine inverse, and tan inverse. Again, just so you know. Okay, so let's go right away here. We want to find the missing angles and we'll round each to the nearest degree. Okay, so again, process is still the same here. This is the angle that I have in question, and with relation to that angle, I want to know if I have the sides opposite, adjacent, hypotenuse, and again, we're going to use our good old mnemonic device here, SOHCAHTOA. So with relation to x, that 7 is the side opposite, and that 25 is the side directly across from the right angle, so that's my hypotenuse. So I have my opposite and my hypotenuse, which means I'm going to have the sine. So I'm going to have the sine of x equals 25. Oops, sorry, not 25. The opposite side there is 7. 7 over 25. Okay, so again, now I'm going to go into the calculator and I'm going to figure this out. So the first thing I'm going to do is I'm going to divide 7 by 25. Okay, I'm going to tell you what you get right now when you do that, just so you have it and we can look at the next step and when I come back and write it. So when you do that, it's going to end up with an answer of 0.28 or just 0.28. So now to find what the measure of the angle is going to be, I'm going to hit second, then the sine key, and then 0.28 and hit enter on the calculator, and it's going to give me my degree measure. So let me go into the calculator here. Again, I'm going to make sure that it's in degrees. It's not. Let me change it. And second, quit. Again, on yours, you're not going to have to keep changing it into degree mode. It's because of the app that I have on my iPad. It constantly turns itself back off. Okay, so again, I did 7 divided by 25, and I got my answer of 0.28. So again, sine inverse is above the sine, so I'm going to hit second, sine inverse, and then I'll just type out that 0.28 and hit enter, and there I am. Okay, again, we want to round to the nearest degree, so that's the nearest whole number. So in this case, that's going to be 16 degrees. So go back in here, and again, 16 is going to be my answer there. Okay, so 16 degrees is the measure of that angle. Okay, next one, with relation to theta, 8 is directly opposite that, and 5 is right next to it. That means that that's adjacent. So in relation to SOHCAHTOA, for opposite and adjacent, I'm going to be using tangent this time around. So I'm going to have the tangent of theta equals the side opposite, which is 8, over the side adjacent, which is 5. Hey, again, if you don't like the word theta, just put x in there. Hey, so again, go into that calculator. 8 divided by 5, then second tan inverse of that decimal. And when you round to the nearest whole number, you should get an answer of 58 degrees. Again, make sure you're playing along and figuring out how to do this on the calculator so that you know how to do it when it comes time for the test. Again, I have theta in C, so with relation to this angle, 12 is going to be the side that is directly adjacent to theta, and 17 is the side directly opposite my right angle, which means that's my hypotenuse. So I have my hypotenuse and my side adjacent. Hypotenuse and adjacent is going to be cosine. So this time we're going to have the cosine of theta is going to equal the side adjacent, which is 12, over my hypotenuse, which is 7. So 17, sorry, not 7, 17. Okay, so 12 divided by 17 on the calculator, and this time we're going to hit second cosine inverse. And when you do that, theta should equal 45 degrees when you round to the nearest degree. Okay, so again, not only can I use this in just a regular old picture that isn't a real world example, we can apply this to the real world here. Okay, so it says find the angle measure from the buoy to the top of the tree, round your answer to the nearest hundredth. So again, I'm looking for that angle right there. So again, with relation to x, that 28 is the side directly opposite, and the 40 is the side directly adjacent. So again, in relation to my SOHCAHTOA, adjacent and opposite is going to be my tangent. So I'm going to have my tangent of x equals the side opposite, which is 28, over my side adjacent, which is 40. So again, you're going to do 28 divided by 40 on the calculator, then second tan inverse of that decimal. And when you do that, you should get an answer of 35 degrees. Okay, and then again, you can be given a problem where you have no picture and you're going to have to come up with a picture on your own. So when a plane had flown 4,150 feet from the airport where it had taken off, it had covered a horizontal distance of 3,660 feet. What is the angle at which the plane rose from the ground to the nearest degree? Okay, so again, I know I have to have a right triangle here. Okay, so the plane's going to take off, and again, just remember this horizontal part is your ground. So the plane's going to take off from the airport. So let's say that's my airport. It's supposed to look like a house. I didn't even draw my house good, but that's your airport. Okay, so there's where the plane's taken off from. And all of a sudden, when the plane gets to here, it's flown 4,150 feet. So that is going to be my hypotenuse, is going to be the distance that the plane has flown. The horizontal distance, again, horizontal distance is going to be the distance between the airport and that right angle there. That's going to be 3,660. And we want to know the angle at which the plane rose from the ground. So x is going to go there. So with relation to x now, 3,660 is your side adjacent, and that 4,150 is your hypotenuse. So again, I need to determine which trig function deals with the adjacent and the hypotenuse. Adjacent and hypotenuse is your cosine. So you're going to have the cosine of x equals the side adjacent, 3,660, divided by my hypotenuse, which is 4,150. Again, go into that calculator, do the division first, second cosine inverse, and when you round to the nearest degree, you should get an answer of 28 degrees.